Hello. In this short video I'm going to show you how I hacked my NES controller into a lefty. Full disclosure, I'm not an engineer, I don't know much about electronics, but I know enough to build tube guitar amps. First I'm going to show you quickly how the controller, or rather how the buttons work. The buttons act like switches. By default they are off, and when you push a button down, the switch is on. Looking at the schematic, on the left you can see 8 switches, each assigned to a different button. One side of those switches is connected to ground and the other side goes to a specific pin of the integrated circuit, which I'll refer to as IC. For example, if I press the button A, the switch goes on, and let the signal flow between ground and pin 1 of the IC. If this isn't clear, don't worry, you'll see what I'm talking about in a few. Now we are looking at the datasheet of the IC. As you can see, there are 16 pins, one row from 1 to 8 and the other row from 9 to 16. Now once the board is flipped, the pins are reverse, so pin 1 is now on the bottom right, and pin 8, bottom left, is ground. Back to the schematic, I highlighted the ground signal in red. You can see it goes from pin 8 of the IC to one side of the buttons. And this is how it transfers to the PCB, printed circuit board. Now with all the buttons highlighted. Pin 7, yellow, is the right button. Pin 6, blue, is left. Pin 5, pink, is down. Pin 4, orange, is up. Pin 1, brown, is A. Pin 15, turquoise, is B. Pin 14, violet, is select. Pin 13, purple, is start. This is a little test to demonstrate what I was saying about switching. If I take a piece of wire, which is the equivalent of an always-on switch, and jump pin 8 to pin 1, the piece rotates clockwise, because pin 1 is the A button. Pin 7 is the right button, so when I jump pin 8 and pin 7, the piece moves to the right. Pin 6 is the left button, and when jump to pin 8, the piece move the left. Now what we want is to reverse our controller. This means that we have to swap left and right, pin 6 and 7. Up and down, pin 4 and 5. Start and select, and pin 13 and 14. A and B, pin 1 and 15. Once again, all buttons are tied to pin 8, which is ground, so we don't have to touch this one. Before swapping those buttons, we need to break the connections from the IC to the buttons. In order to do that, we have to cut the traces. Before cutting those, I made sure they were away from the buttons and consequently from the rubber contacts. I used a cutter. Go gently and pass over your cut till you break the copper trace. You don't have to go deep and large. For our future connections we have to scrape a bit of the trace, about 5 mm. To reveal the copper and be able to get the solder on, you want to scrape the side of the cut that goes to buttons. I pre-soldered them to make sure the tin was sticking to the copper trace. Now you can see I soldered the revealed copper of the right button, which used to go to pin 7, and now is soldered directly to pin 6. So now when I press the right button, the piece moves to the left. Yet it's working. 1 button done, 7 to go. Fast forward. This is what it looks like when it's all done. I know it looks messy. Could it be a little cleaner? Surely, but with those many connections in such a small space it's bound to be messy. And the shorter the pieces of wire are, the harder it is to work with. Don't go heavy on the solder. Like I said, I pre-soldered the copper traces. I also tinned the ends of my wires. Make your connection and pull the wire to make sure it's done right. And now the moment of truth. The small lag between me pressing the buttons and the piece actually moving is due to the video capture process. Just another small sequence to show you that all buttons work fine. If you are not familiar with NES Tetris, the select button show or hide the next piece. I hope you enjoyed my first video editing job ever. I mainly hope this will be helpful to some of you. Cheers.